This is lesson 1.6, representing functions as rules and tables. You should be on page 35 of your textbook. Vocabulary. A function. A function consists of two things. It consists of a set called the domain, which contains numbers called inputs, and a set called the range containing numbers called outputs. As you hear that, that might not make any sense. So I want to give you a little example, and then we can put these in our notes. I like to think of a function like it's a computer. And this is a special kind of computer. You can input a number into the computer. The computer will do some math operation to it, like add, subtract, multiply, divide. And then the computer will, after it's done the operation, will output a number. And that's what a function is. Here would be a visual example of that. Like, let's say I inputted 1 into my function, and the function outputted a 3. I then inputted a 2 into the function, and the function outputted 4. I inputted a 3, and the function outputted a 5. I'll do one more. I'll input 4, and the function outputted 6. You can probably look right now and say, I know what the function's doing. I'm taking x, I'm adding 2, and it's giving me the output y. That's what a function does. What I input is called the domain, and what I output is called the range. We often write that in table format. I'm sure you've seen a table before of this nature. So if I input 1, we said the output was 3. If I input 2, the output's 4. If I input 3, the output's 5. And if I input 4, the output's 6. So let me kind of color code here. The domain and the inputs, these two terms you can find right here with these numbers. These numbers would be called my domain. They're also called inputs. My range, those are the numbers that the computer produced after doing the plus 2. Those numbers would be here. 3, 4, 5, and 6 are called the range. They're also called the outputs. One other characteristic a function has. Each input can only be paired with one output for a function to exist, or for a group of numbers to be considered a function. Here would be an example of a function. If I input 1, I get 7 for an output. If I input 2, the output's 10. If I input 3, the output's 13. If I input 4, the output's 20. Do you notice how each input gives me exactly one output? Each input gives me exactly one output. This would be a function. I'll put a little check mark by it. Here is another function. If I input 1, the output's 5. If I input 2, the output's 5. If I input 3, the output's 5. If I input 4, the output's 5. Now, I sometimes have students mistakenly say, this isn't a function. Let me be clear. This is a function. Here's why. If I input 1, it only gives me one output. It gave me a 5. If I input 2, it only gave me one output, a 5. Yes, it is the same output as 1, but it only gave me one output. If I input 3, I only get one output, 5. If I input 4, I get one output, a 5. Here would be an example of something that's not a function, because right here and right here, do you notice? This is saying if I input 1, I could get 3, but I could get 4. I didn't get one output, I got 2 different outputs. Or if I input 2, my output could be 5 and it could be 6. That's not exactly one output. The input 2 is giving me 2 outputs. So this would not be a function. The prior 2 would be. Let's look at this example. The input-output table shows the cost of various amounts of regular unleaded gas from the same pump. Identify the domain and range. Now, when you have a horizontal table like this, the top is always the inputs. The top is always X, and the bottom would always be the output. It's always the Y's. Okay, let's find the domain and range. Here's my domain. Those are the numbers we inputted into the table. There is my range. Those are the numbers that were outputs. When they ask you in the directions to identify the domain and range, right here you see a note. We want to write those out. We can't just circle them. We're going to write them out. So on a paper or homework or quiz or test, you'd want to write it the following way, like they have here. The domain is 10, 12, 13, 17. The range is 19.99, 23.99, 25.99, 33.98. Pause the video right now, and I want you to try on this problem. I want you to identify the domain and range of the function. Here's what you should have came up with. Your domain is right here, and you would write it out. 0, 1, 2, 4. Your range, it's right here. You would write it out. 5, 2, 1. Since 2 is used twice, you don't have to write it twice. I want you to notice this table is a function. Each input only gave you one output. Inputting 0 only gave you a 5. Inputting 1 only outputted a 2. Inputting 2 only outputted 2. Inputting 4 only outputted a 1. That's a function. Let's talk about a mapping diagram. A mapping diagram is this type of picture. You notice it looks like a table, just a little different. This mapping diagram in the picture is showing me that if I input 1, my output is 0. If I input 2, my output is 1. If I input 3, the output is 2. If I input 4, the output is 2. If you wrote this picture, this mapping diagram, as a table, it would look like I have here. Let's go down here and let's identify if these are functions. Tell whether the pairing is a function. Example A is not a function, and here's why. I'll circle it in red. Do you notice how the input 0 is giving me 2 separate outputs? A function can only have one output for each input. That's not a function. B, this, I'll put a little check mark by it, this is a function because each input is only producing one specific output. Your turn. I want you to try these. Tell whether the pairing is a function. All right, let's check. This is a function. Each input only gives you one output. This table is not a function. Do you notice how the input 2, let me write that out here, 2 produces 2 outputs. And you can see them, I circled them. Okay? 2 can produce the input 0, but it also can produce the, I misspoke. The input 2 can produce the output 0. The input 2 could also produce the output of 1. That's not a function. Okay? Function rules. A function can be represented by using a rule. I'll talk about what that is in a minute. That relates one variable to another. The input variable is called the independent variable. So I wrote a little list of things here. These four things all kind of mean the same thing. The input, the domain, the independent variable, and x are all referring to the same thing. Like when I look at this table here, all these numbers would all be represented by any of those terms up here. The output variable is called the dependent variable because its value depends on the value of the input. In other words, for me to get, when you look at this equation, y equals x plus 3, if I input a 0 in the equation, 0 plus 3 gives me an output of 3. To get 3 as an output, it depends on me putting 0 as the input in. That's why I have these values here are called the dependent variable. Let me quickly circle those. Here are my dependent variable numbers. So output, range, dependent variable, and y all tell us the same thing. I'm going to get to this more in a minute at the end of the video. We'll talk about this more. Make a table for a function. The domain of the function, y equals 2x, is 0, 2, 5, 7, and 8. If that's my domain, those are the numbers I'm going to plug into my computer. Make a table for the function. You can see I'm doing that here. And then identify the range. Let's make the table. Okay? Here's my picture. If I take 0 and I put it in the computer's going to take 0, double it, and then produce an output. Well, let's check. If I take 2 times 0, I get 0. My output would be a 0. If I input 2 into the computer's going to take the 2, it's going to double it and produce an output, which would be 4. If I input a 5, put a little arrow here again, 5 into the computer, 2 times 5, 10. 7 doubled would be 14, and 8 doubled would be 16. Okay? The numbers I highlighted in blue, those are my numbers that are considered my range. They want me to identify the range. So let's write those out. My range in this problem would be 0, 4, 10, 14, 16. The next thing, what does it mean to write a rule? I told you I'd talk about rule in a minute. Rule means write an equation. It means write an equation. Let's find the rule for this particular function. If we input 0, we get 2. If we input 1, we get 3. If you input a 4, you got a 6 as an output. If you input 6, you output an 8. And if you input 10, you output a 12. Are you noticing that on this table, we have a +2 pattern? We keep on taking the input. I drew a little picture here. We're taking the input, which is x. We're adding 2 each time, and that's producing an output. So the rule, I wrote it here, the rule would be that the output equals the input +2, or y equals x plus 2. You could also get the rule by doing the following. In case if you couldn't figure out the pattern, you could get it by entering this table in your calculator, doing what's called a linear regression, and it would produce the rule. If you don't know how to do that, ask, and I can show that process in class. I don't have time on the video. Last thing, you're going to have a worksheet you're going to fill out that's going to look like this, which if you look a few screens earlier, when I said I was going to skip this part over, I'm talking about it right now with this table on this worksheet that you'll get. So here, let's work through these together. Here's an example. Here's my verbal rule. The output is 3 less than the input. Now remember, the output is the y's, and the input is the x's. Now I want you to notice, a verbal rule, we always use the terms output and input. You would never say y and x. Verbal rule, we use output, input. So this is saying y is 3 less than, which means take away 3, 3 less than x. There's my equation for the verbal rule. Okay, let's go to this now. Here's my table. My domain is 1, 2, 3, 4. So if I put a 1 in here, 1 minus 3 is negative 2. If I put a 2 in here for the input, 2 minus 3 is negative 1. If I put 3 in here for my input, 3 minus 3, the output 0. If I enter in a 4 as my input, 4 minus 3 is 1. Can you see the range right here? We need to write it down. My range is negative 2, negative 1, 0, 1. Let's graph that. Okay, I'm going to try to color this in a little bit. There's my x-axis. There is my y-axis. 1, negative 2 means 1 right, 2 down. 2, negative 1 is 2 right, 1 down. 3, 0 is 3 right, 0 up or down. And 4, 1 is 4 right, 1 up. There is my graph. Do you notice how those points are lining in a straight line? If they are not lining in a straight line, you know you screwed something up. Let's go to this next row. Here's my equation. Do you notice how the output, y would be the output, so I'm going to write that in here. The output is 5 more than the opposite of the input. Those words I wrote right here. There's my verbal rule. Okay, let's make our table. If you plug a 2 in here, the opposite of 2 is negative 2, and when you add 5, you get 3. When you put 4 in here, the opposite of 4 is negative 4. When you add 5, you get 1. When you enter in a 6, the opposite of 6 is negative 1, and you add 5, you get negative 1. And when you enter in 8, opposite of 8 is negative 8 plus 5 is negative 3. All I have to do is plot those points. 2 right, 3 up, 4 right, 1 up, 6 right, 1 down, 8 right, 3 down. This last one, they gave me the points but nothing else. Okay, well if I have the points, let me write them in my table. The first point is 0, 2. I see 1 right, 3 up. I see 2 right, 4 up, and 3 right, 5 up. Let's write the domain. It's right here. The domain is 0, 1, 2, 3. The range, 2, 3, 4, 5. Let's get our equation. What's the pattern? Well, it looks like I'm adding 2 every time. My rule, my equation, which is also called the rule, is y equals x plus 2. The verbal rule, the output is 2 more than twice the input. That's a good detail of how to do this lesson. I'm going to stop the video here. If you have questions, let me know.